Hello, welcome to Stroma Insights podcast number 3 with me, Stuart Oakes, and my guest today.
Hi, it's Richard.
Hi, Richard. Richard is one of our principal consultants, and today we're going to talk about measuring the invisible, as somebody said, is the looking at performance measurements of building as opposed to just assessment of building, which we'll go into in more detail, specifically around HTC. But there are a couple of bits we're going to talk about as well. How it's fitting into the future. Well, the future of retrofit, I suppose, but, is there a place for this in new build? Spoiler, I think there very well may be. So, it's January 2026. Happy New Year, everybody. I'm in the middle of winter heating period. Everyone's got their heating on all the time. Therefore, people are spending more money on energy. We've had the energy crisis. Energy's just become very expensive, so it's become at the forefront of a lot of people's minds. So that's kind of driven and does drive energy efficiency in buildings. The more efficient we can make our buildings, the less energy we will use, therefore the less the cost it will be, and then ultimately, depending on where that energy comes from, the amount of the emissions become less. So up until sort of now, for the last 20 years at least, we've relied on in dwellings, SAP ratings and EPC assumptions, and that's the word, and that's done by ratings, that's done by assessment, and that's theoretical performance, isn't it, Richard?
Yeah, very much so.
Which is an average of an average. It's a process by which the National Calculation Methodology, SBEM, in non-domestic buildings. But today we want to dive into actually looking at that metric. Is it actually changing? Just because it says a building performs well on paper, does it perform well in real life? So, Richard, do you want to kick off?
Yeah. So HTC, or heat transfer coefficient, it's a move away from theoretical analysis of a building to actually measuring and looking at the building in practice and seeing how it's actually performing, which, as is well known in the industry, there's a massive performance gap, particularly between, for example, SAP and actual performance. So this is looking at trying to actually measure that performance in the real world using a test.
Do you want to kind of highlight how that and outline how that process happens, what we actually do on site, what it leads to, how we get a number?
So we use a process at the moment which we place a number of sensors around the building that we're looking at, and we would look at a whole house. We place on average in a house maybe 5 sensors. And what that does is, over a period of 21 days, it will measure the temperature and the humidity of that space. And from that, we take that data and we analyze it, and we put it together, and it will work out what the heat loss of the building is.
We do need to take a note of the consumption in kilowatt hours from the meters, don't we, as well?
Yeah. So there's very minimal data taken, but we take essentially metered data. Ideally, if you have a smart meter, we can access that data with your permission. We can use that in the analysis, and we push that all in. And what it comes back with is a figure of the heat loss of your building as an average.
So that's the whole envelope. We can't at this point, but we're going to talk about other techniques in a bit. But this looks at the whole envelope, if you will, the box that contains the conditioned air.
Yeah. The other bit we would do as part of that process generally is we would do an air test of the building, although it's not absolutely required. It's preferable to do it.
Because having an accurate air test infiltration rate it makes the whole test more accurate, doesn't it?
Yeah, it allows us to separate that and look at the fabric in isolation. If we've had to assume that, then there's a certain proportion that will be at risk of not being as accurate, but it can be done without if necessary.
And essentially, then we get a U value.
Yes.
An actual U value for the performance of that. We're swapping between building and house, dwelling. We're using all kinds of terms here casually, but this can be done in any building if the principles are the principles. So just because we use dwelling doesn't mean we're only talking about dwellings. Do you just want to do a quick U value? What U value means? We say this term a lot, but just wanted for the listeners who might not know.
So a U value is a measure of the rate at which you will lose heat through building fabric. So you'd typically talk about the U value of a wall, and it's in watts per meter squared Kelvin, and it basically is how much heat will go through that construction over a meter squared. And what we get from the HTC is essentially an average U value of the whole building. So that will include your walls, your floors, your roof, and your windows and doors.
And this HTC measurement is an input in SAP and SBAM, isn't it? So there is a calculated number you can compare it against.
Yeah, in a new build, you would get the SAP calculation gives a HTC for the building, which is based on the theoretical information you put in. But you are able to, in new EPCs, using the RD SAP software, which is for an existing building, we are getting to the dwelling. Sorry, yeah. You're getting to a point where we can put the HTC values in. It's not quite there yet, but we are led to believe it's coming fairly soon, and that you'll be able to put this measured value in and improve your EPC rating.
And then what we're finding in terms of, I think maybe it's an obvious question, people come to this conclusion naturally, are we finding that things are better or worse than the calculation on average? I know we're talking average, but what do you find the trends to be?
To be honest, it can be all over the place because it depends a lot on the maintenance of the building. If it's a well-maintained house and they've kept it up, and made sure they've repaired damage and things like that, generally they're performing okay.
I think there's an assumption that old houses are not as energy efficient as new houses, but actually, in times gone past, we've built very thick walls, so we've had very big thermal mass to help us. We've used wet plaster, which has blocked up holes for infiltration, so they can be quite airtight and can be quite thermally efficient, can't they?
Certainly, yeah. We've done some tests on some very old buildings, 200-300-year-old buildings, and we found the performance of them actually is pretty good. But you are talking sort of half a metre to a metre of masonry, in those constructions, which does perform thermally quite well.
Yeah. So we've talked about in my introduction about using this in retrofit. I suppose that the point of this in retrofit in the end is, if you do it before you do something, and then after, it's a great way of you're comparing absolutely apples with apples, because the house, the dwelling, the building is the same, and you can actually see empirically the building has improved by a number rather that is measured.
Yeah, and there can be funding streams linked to those sorts of things, which you need to measure to prove that you've done something that is worthwhile.
Absolutely. And then specifically, I know we get inquiries about the whole world of heat pumps and retrofitting heat pumps in existing buildings. Absolutely key to work out what the actual heat demand is on that building, isn't it? For sizing it correctly.
Absolutely. So I'm in the process for going in and changing your house from a gas boiler to a heat pump. Yeah. In order to do that, they have to make an estimation of what the heat loss of the building is. Now, they have calculations that they can fall back on, but they are, at the end of the day, still only estimates, and they will walk around your house and they'll look at it and go, it's about this old, it will have a performance of roughly this, and then they'll lump a chunk on top just to be safe.
And then if we're comparing that with putting a new gas boiler in, the margin of error with a heat pump is considerably less, isn't it? If you undersize it, you'll never get the house or the building anything like warm enough. And if you oversize it, you'll end up using more electricity than you need to use.
Absolutely. And I mean, controversially or not, I mean, there's a lot of stories out there that say that heat pumps aren't suitable to houses and aren't suitable to old houses. That's not the case. It's more a case that they need to be sized correctly to do the job. At the end of the day, it's just a box that produces heat in a different way to a gas boiler.
Yeah.
And if you can size that to do the job, it will do what it's supposed to do. But if it's sized incorrectly, you'll always have problems with it.
So those old rule of thumb stuff with gas boilers, you used to hear the guys say that 2 kilowatts per radiator, all that sort of stuff was kind of okay with gas because it was kind of cheap and kind of didn't really matter. And they'd work at a temperature that was themselves, but a heat pump doesn't. A heat pump works in a different way, which we're not going to go into in this particular chat.
Very simply, it's you burn gas, you get the same amount of calorific value or heat out of it when you burn it, no matter what the temperature is outside. With a heat pump, it operates in a different way and is affected by external air temperature.
Yeah. So just go back a bit of history now. We used to measure HTC. I mean, HTC is not a new concept, and we've been talking about it in the energy efficiency industry for probably, I can remember having rigs probably 15 years ago, where we used a thing called a co-heating test, which I suppose gave you the same sort of result, but had disadvantages, I think, because it involved basically being out of the dwelling or out of the building, didn't it?
Yeah, it was a shorter test, but it involved you controlled the amount of heat that went into the dwelling, and you measured it all, and at the same time you measured the temperatures and essentially it heated it up, and then it measured how long it took for that heat to dissipate.
And I suppose that's fine, but you've got to be out of the house, which is inconvenient. And actually, if you're going to do it over a longer period of time, and you should do it during the heating season, it's not going to give you the particularly accurate result in the summer if it's too hot. It actually takes into account how people actually live in that house, doesn't it?
Yeah, it does. And certainly it's it's very non-intrusive. We've got a few sensors around the building, and as long as they're not stuck over the top of a radiator or a heat source or sitting in a window, then it doesn't get in the way.
So we've talked about putting the sensor in the house. We've talked about leaving it for about 3 weeks. We've talked about getting the data. Then what happens then, Richard?
We take all that information and we put it into a system where it calculates it. And it looks at all of that information you've given. It pulls some other data from other places. So, for example, external weather data is pulled from a national database for the nearest location to your house. And there's a lot of those. They're not just airports like a lot of people think. There is a lot of data out there, and it puts it all together and it analyzes it and comes out with the numbers at the end. And it also comes up with a bit of an error margin as to how valid they feel that result is.
But during the winter, when it's cold outside and we've got plenty of heat being consumed, the error margin becomes quite small, doesn't it?
Yeah. I mean, in theory, you can do this test in the summer, but the reality is that your error margin just gets much bigger. Yeah. So we don't tend to do it. It tends to be done during the heating season.
It's a bit like thermography like that, isn't it? In the sense that obviously thermography needs it to be dark, but also thermography needs a kind of heat delta between the inside and the outside, ideally of at least 10 degrees. So certainly this week, in second week in January, it will be perfect time to do it.
I think ideally we're looking for an average delta T of about 7, I think, for this one.
Which is easily achievable, isn't it, at the moment?
Yeah, absolutely.
And will be probably until March, April time. So it's probably from October onwards. So, you've got a reasonably good period to have a look at this. And as we've said, the beauty really is bring these little sensors in. They're non-intrusive. Leave them in the property with no kind of no interaction required. So return on investment. We've already talked about heat pumps and making sure you size heat pumps right. If you size a heat pump right, then you can definitely save money. We'll perhaps do one on electric heating, a podcast on electric heating and how it works in calculation and things like that in the future. But I quite like this sort of. We've talked again about, I suppose we call targeted retrofit. And I think what it does, Richard, is it doesn't guess. It takes the guesswork out of doing things, so you can target. And there are other things that we're going to talk about, perhaps in a minute, thermography and 3D U-value testing, which can perhaps be more, if you will, precise in terms of actual points on walls or points on the envelope. But, knowledge is power. And,
absolutely.
And we go in, at the moment, what we can do with retrofit is we can go in, do a calculation, probably, as you've mentioned, using RDSAP if it's a dwelling, which makes a whole lot of assumptions because in the world, in real life, you don't know what's in a wall. You can say that house has probably got a cavity wall. You can say that house may have a filled cavity because you judge when it was built and what building regulations were at the time. But as we all know, things degrade over years. So, this is the ideal time, and it really will help you target, particularly if you've got limited funds, find out where your problems are, yeah?
Yeah, I mean, absolutely. I mean, you can measure, your heat loss of your building, and if all you're going to do is put a heat pump in, that's great. It gives you a number to use in that. But if you want to go a stage further and start looking at, you've got some money for retrofit, and they're saying, look, we've got some money to put some insulation in. Where do we need to put it? Well, you can do this test as a starter, and it'll give you an idea of whether that's going to be an effective thing to do because there's a lot of heat loss. But you could then tie that to a secondary test, for example, the 3D measured U-value testing, where you can start to look at the wall in isolation. It uses a slightly different testing methodology where you've got a thermography camera, but it allows you to then look at that particular wall in isolation and then go, maybe I should put it there.
For those that this concept's new to, you just want to outline what 3D U-value testing looks like?
Absolutely. So it's a relatively new on the market. So, I mean, I say relatively new. It's been around a little while, but it's come into more practical use more recently. It's taking an existing building. We get a thermography camera, which looks at heat transfer through objects, and it allows it to point it at a wall or a floor at the moment, and you can then measure what the heat loss through that wall is and give an individual
at that point
for that point that you look at. And it generally looks at sort of a meter squared area or a wall, and it allows you to actually measure in situ what that is, which, while it seems very simple to say, oh, well, it's this, it's actually quite hard to measure.
Yes.
At the moment.
Because as we said, we might use RDSAT, we'll get an assumed U value of a number of say 0.25 or something. But if it's better than that, well, are you arguably wasting your time insulating that wall if it's already performing?
Yeah, exactly. You might go and do this test and go, well, we've got
it's
a
worse
HTC,
than that, of course.
and you might measure your HTC and go, right, I'm losing loads of heat, and then you go, right, well, let's look at the wall and see if that's where we should be putting it, and you might find that the wall is performing really well, and from that you go, well, maybe we need to target putting in the roof.
And then that segues very nicely into thermography, which again has been around for ages. Thermography is what we all kind of, with the sort of the blue and the red patches on the walls and the roofs. I was looking at, we've all seen these thermographic images. We use them for other things as well. We use them for looking at electrical boards and finding hot spots and stuff like that. But it gives you a good, easily understandable visual of a building, doesn't it? So you'll always see, depending on which way you're looking at it, from the inside out, the outside in, probably the outside in, you're looking at the blue patches will be where the windows are, but what you're looking for is really those blue patches on non-consistent bits, aren't you? Like in walls, on roofs.
Yeah.
Which give you a good idea to go and look somewhere, doesn't it?
Yeah, certainly in older buildings, there's a thing known as your insulation can slump over time, and what happens there is in the cavity all your insulation falls down and lands at the bottom, and a thermography camera or test will be able to go and find that out for you, because you'll see that it's very warm at the bottom. At the top it's very cold.
Also good for cold bridging and stuff like that.
Yep. Yeah, if you've poor window performance, if there's leaks, you can see that, or as you say, cold bridging. If you've got a particular construction where it's you've got big steel beams or something, for example, it will show that up in the thermography. You'll see it.
Yeah. So do all that, you get all this data, this empirical stuff, and then then you go and do your retrofit. And then, of course, the good thing then is you've got a really nice guarantee thing to compare it, haven't you? Because you measured that building before you did it. You do what you're going to do, and you go back, and then hopefully you see it's all good. So it's great for quality assurance, isn't it?
Yeah, absolutely. Which is, we talk about the performance gap all the time. Particularly, from new build, but it's great to be able to go in and actually look at a building and go, well, here is the actual performance, and we can do something about that, and here's the result of whatever we have then done,
which can then be fed into sort of more broader calculations by looking at consumption data and all that kind of stuff again, can't you?
Yeah, you can use it beyond that, but yes, as I say, there are things where you can start doing more elaborate versions of HTCs that are live, but the honest answer is they're great if you've got a particular purpose for them.
Yes.
If you're just looking for how to spend your money in the best way, this is brilliant for that.
Yes, and relatively inexpensive, and certainly I think so. Well, I'm going to say that, obviously. But that sort of segues into the new build opportunity as well, in the same way as we do air testing, essentially as a quality assurance test of a building, because we lose heat out of a building by either going through the walls because the U values are high, as previously talked about, or because warm air or cold air for cooling it is leaking out of unintentionally out of buildings. Now, obviously, we talked about air tightness testing a couple of episodes ago. I will always caveat when I'm talking about infiltration with ventilation. Infiltration is non-planned leakage, whereas I suppose ventilation is, and you absolutely need to ventilate buildings for reasons of damp and other things. But it's all about control. It's all about knowing what you've got. So if we measure the air infiltration rate by doing an air test, why couldn't we do this? What we've been talking about, particularly on the sample, because at the end of the day, we talk about retrofit. If we're talking about a lot of, say, an estate somewhere, most houses are going to be built the same. Therefore, it's a fair assumption to say that if we do a sample, it's going to be indicative of what's happening everywhere else if they're all the same age. So same with new houses, isn't it?
Yeah, absolutely. I mean, the story is, I'm sure you've already done in previous podcasts on the air tightness testing. It started small in the building regulations, and we're hoping at some point that they will adopt HTC into the building regulations for new builds as a means of demonstrating, like we have done with air testing, that the building is performing as it's supposed to.
And I think residents would have a lot of comfort with that, wouldn't they? Because I think more residents now are looking at people are buying houses are looking at energy performance because of the price of energy. For years, energy was cheap, so it sort of didn't matter. But now it does, and quite rightly it does. So people look at the EPC rating, which is one way of looking at the energy efficiency, but again, done by assumed values, and assuming that everything was absolutely as it should be in the design. So, at the end of the day, if you could tell someone who's moving into a house the air tightness rate is an amount and the HTC rating is is X, then you're putting a rubber stamp on the quality
Absolutely.
assurance on the work that's been done, aren't you?
It's probably the most expensive thing you'll buy in your lifetime is a house, and you want to know it performs. And you wouldn't go and buy a new car, and the first thing you're going to look at is, well, what's the miles per gallon, or how many miles am I going to get out of my battery?
Yeah,
you'd like to know what your house is going to do.
Yeah. So I suppose stop guessing and start measuring.
Absolutely.
It's quite a neat way of putting it. So that was really useful. So if you've got any more questions about this whole subject, give us a shout. Come to stroma.com or contact us. Reach out, ring us up, whatever works for you. We're happy if you've got a situation you think this could be used in. We're delighted to have a chat with you and look what you're trying to achieve and see if it'll work for you. So I think we'll draw a line under it there. Richard, I really appreciate your time today. Thank you for your input, and we'll speak to you next time on the next episode. So for now, thank you very much.
Thank you.
Bye bye.